This is Ramu, Dean, Skill Development, Institute of Aeronautical Engineering, Hyderabad. In the series of FANG coding interview questions, today we are going to see the new problem. The problem is rotated images. Before going to the description of the problem, let us see the companies ask the particular question in their interview process. Mention there the Cisco, Amazon, Facebook and Microsoft, and Google also asked this question in their interview process. Right? And try to consider this problem. Right? Here, you are given an n by n 2D matrix. They will give the n by n 2D matrix. And your task is, see, 2D matrix representation of image. You know that all the images is going to represent in the 2 by 2 matrix only. Sorry, 2D matrix only. And rotate the image by 90 degrees clockwise. Right? This is your image. You need to rotate your image 90 degrees clockwise. And how to rotate the image in place? In place means don't use the extra space. Extra space means the space of this particular problem should be big O of 1. That is called as a in place sorting. In place change. Right? Which means you have to modify the input 2D matrix directly without copying or without doing anything. So you should change the matrix in place. Don't allocate the another 2D matrix. Do the rotation. See, for example, this is your matrix, and see, if you convert the 2D matrix, see 5 is comes to here, right? This everywhere you will get a 90 degrees of rotation. Just observe that, and everywhere you have a 90 degrees of rotation. How to possible this one? And what is the time complexity? The time complexity is very clear. It's the size of an array. That's all. Right? What is the matrix size? That is the time complexity of the given problem. Then how to solve this problem? Observe clearly here. If you see the indexes, is a 00, 01, 02 and 03, right? Yes or no? This one is 10, 11, 12, 13, right? 20, 21, 22, 23, right? 30, 31, 32, 33. And if you observe that the 00 is goes to where? 03. Yes or no? 00 is goes to 03. And 03 is goes to 03 is goes to 33. Next, same. The 33 is goes to where? 30. Next, 30 is goes to 00. Yes or no? And like that, 01 is goes to where? 13, right? 01 is goes to 13. So based on this, you need to create the formula. So how to move the data? That is very, very important. The moving of data is very, very important. How to create the formula for this? Here, what I'm going to do here, see, I'm going to store this one as a temporary, right? I'm going to use that one as a temporary. Initially, t is a temporary value, right? And for example, this is I'm considering as a M matrix, right? How to get that? So I have a I index, J index, and end is the length, right? For example, this value is 30, right? 3 means, what is the 3? 3 means the row, right? Which column? And after that, next I need to move here, and next move here, next move here, means I need to change my, what should I do here? I need to change my indexes, rows, right? Rows. I'm going to change the rows, right? So that is why n minus, observe clearly, n minus, I'll write some more larger. So t equal to m of n minus j, right? Minus 1. And what is the row? This one is 0, right? And sorry, 0 means that is the initially, that is the I index. And this one I stored in the temporary variable. Now my task is I need to copy this one to here, right? From here to here. Yes or no? From here to here, and here to here, here to here, and here to here. That is my task, right? So observe clearly here, when I'm going to change from here to here means, and m of n minus j minus 1 of I, you can write as it is, equal to, then you need to move from here to here. Observe clearly, here to here. Then you should use m of n minus I. The reason is, if you write j, every time that will change. But here, only I need to change my column, not row, right? That is why I should use here I, and here I should use the j, because this is the column part, right? I need to change my column. That is why I should change here. And same, observe clearly, m of, same formula, write it here, n minus I minus 1 of n minus j minus 1. Here, this value is stored here, right? This value. Now, you need to change your, rows. Yes or no? Should change your rows. Initially, the row is at the 0, 1, 2. So that simply m of j, right, and n of I minus 1. Here, my row is only changed. My column is constant. That is why I just use the I here. Then same. M of j of n minus I minus 1 equal to, so this value comes to here, right? This is ij. Right? Now, observe clearly, my temporary value is stored at where? Where should it change? Store m of I and j is equal to t. That's all. When you perform first time, then the first iterations are going to change. After that increment of this one, then it comes to here. The first, what happened? The first iteration, all your these values will change. Okay. When you increase the value, then these values is going to change. Yes or no? But the next time, what happened? These values is going to change. But the next time, if you perform the next time, what happened? Again the values will get the replaced. That is why be careful with that. When your matrix is, you need to check the whether the matrix size is even or odd. If it is even, you need to do one way. If it is odd, you need to do the other way. Right? For example, if it is even, then you repeat the process 2 times. Right? Means, for example, 4 means you have to repeat the 2 times the process. If it is a odd means odd also you should perform the, for example 3 also you should perform the 2 times. Right? You need to check whether the size is even or odd. Let us see the implementation so that you will get an idea on the problem. See, this is a problem. Just now I have seen the problem description, and I'm going to remove all this stuff here. And this is the matrix, right? I simply write M as my, no need to return anything because it's in place, right? So no need to return anything. And here M is there. First I need to check the what is the size of the matrix, right? So it's, anyway you know that this is a square matrix. If you know that the length of M, that's enough. M. So for the row purpose I write a where I in range of n, right? And for j in range of n. Got it? And now I need to check whether the given matrix is even or odd. See, when you perform by 2, then it is a even. I'll get a, so integer division I did here. For example, 3 I'll get a 1 and 2 I'll get 4 I'll get a 2. Right? For 3, what I'm going to do? N modulo division 2. Now, what it will return? For example, if you observe that, if my n value is 4, then the result is here n by 2 means 4 by 2 plus 4 modulo division 2. Then what is the result here? 2 only, right? The value is 2 plus 0. The result is 2. And for example, my n value is 3 by 2 plus 3 modulo division 2. Then the result is 3 by 2 means I'll get a 1 plus 3 modulo division means 1. Got it? This is our criteria, right? So using this formula, we're going to get the required criteria simply. Got it? Now, what I need to do here? I need to store my temporary value. So temporary value is there at the bottom of left bottom, right? Left bottom. So for that reason, M of left bottom. So left bottom is going to move left bottom to left top, right? So here the rows are changing, right? Wherever the changes are there, you just use J there. That's all. And I is a common because I is going to move like this. Initially 0 and next is going to the inner part. You know that if you consider the matrix, first it is going to complete the first part of the matrix and it goes to the inner part of the matrix and it goes to the inner part of the matrix, right? That is why. So initially I is here, next I is goes to here, next I is goes to here, right? That's the reason I. So I just store my t. Now simply I'm going to copy this one and this value is equal to. Now I need to copy right bottom into the left bottom, right? So now right bottom, you know that now right bottom is moving, right? In which way? Left side. Means now columns are changing, right? When the columns are changing, rows is constant. When the row is constant, simply n minus I minus 1. That's all. Right? Now my column is going to change, right? Then you should use the J there. Now observe clearly here. Now top right bottom, top right to top, top right to bottom right. Yes or no? Top right to bottom right means the values are coming down. So means here my row is constant, my column is constant, my row is changing. So row is changing, then I should use a j here because j is initially 0, right? 0, 1, 2, 3. That is why you should use a j here. When it is increasing, then you should use n minus j minus 1. When it is if you consider the bottom to top, then n minus j minus 1. Top to bottom means j only should consider. And now n minus, yes or no, last column, right? Not last row, right? Last column, right? Last column. That column is constant, right? Column is constant. That is why I just use a one here. And now what do you need to copy here? You need to copy from top left to top right. Then simply the values are I and j. Now what I need to copy into this one? M of I and j. Here the biggest task is to creation of the formulas. If you understood how to create these formulas, then it is easy. Right? Now equal to t. Yes. So for the inner part also I should take the 2 only, right? Half time. Yes. The problem is accepted. Got it? Here the thing is you need to identify the formulas. See, this is to copy the left bottom. Need to copy the left bottom, right? And left bottom to copy right bottom into left bottom, and in right bottom you should copy right bottom, so left top, and the left top, right top, and right top to left top, and left top to bottom, left bottom. That's all. This is the way we are going to solve the problem. Got it? And what is the time complexity? This is the n by 2 and this is the n by 2. It goes to the matrix. It is the level of the matrix. That's all. So this is a general problem. There is no any specific idea. Only the thing is you need to identify the formulas. Right? Based on the formulas, you need to solve this problem. Okay. Thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.